Hello, hi, my name is Nafiez. Today I would like to talk about fuzzing, revisiting software security. Thanks to the organizer ROOTCON 15 for the invite this year. So about me, I'm an independent security practitioner located in Malaysia with passion in vulnerability research, fuzzing, reverse engineering, and exploit development. During my free time, I like to play RC Drift. Some of my notable works can be found in the link below. So talking about software security, so we looked into the what makes this still fail. We do see a lot of improvement has been done in the past, and a lot of mitigations takes place, and a lot of research papers are being out there, and a lot of things that we have been reading, but we do still see this thing as fail. So for the example, like a lack of secure development life cycle, we do still see a lot of companies that are still fail and implementing SDLC in their and their software development. And of course, the main problem is we always see is the ignorance from the vendor by trying to avoid fixes. So we do see a lot of companies, even the large tech vendors as well, trying to deny to fix a vulnerability or security issue because they will see like the issue is actually just a small matter for them, but they don't know the impact that affecting customers, millions of customers, a lot of customers, special customers, and so on. So this ignorance from the vendor is basically why we still see all of this fail. And of course, security is expensive. We started to see a lot of companies, a lot of financial institutions, and many other industries started to hire security experts. But of course, we need to know that there's a lot of money, cash flow out in order to get the expert to work in their environment. So yeah, so and of course, this is why we still see it as a failure because security itself is expensive. We don't talk about the people that we hire, but the parameters, security parameters that are being deployed on the environment. Imagine how much the cost to build those things. So like if you are building like a threat intelligence team, there's a lot of parameters, or there's a lot of feeds or any other things that you are trying to implement as part of your team. So same goes to the different area or different domain in security. Everything requires a lot of money. So yeah, security is expensive. And then the next one, third-party software developer do not follow mitigation built by Microsoft. We do see a lot of companies that fail to implement SLR. It's just a small matter, right, where you open Visual Studio and then you can set there SLR. And of course, some vendors, like in the past, I used to work on some vendors where I asked them like, and forced them like, why ASLR is not enabled. It's easy to enable it in the compiler because the thing is exists. It's just that you just choose the option yes or no to enable the ASLR, something like that. And yeah, we still seeing this until today in 2021, where the vendors or any other third-party software developer still follow all these mitigations. There's just the simple mitigations. How about the next gen mitigations, right? Because we started to see exploit developments started to getting harder. However, due to the software developer on the third-party softwares still follow all of these mitigations. And yeah, I do have spoken on some vendors as well last time where they don't prioritize security. Where they see security is like just a small matter. They don't see this as a important affecting their customers. It's just that they know how to make money. So yeah, we can't do much on that, but of course, yeah, we can still tell them like this is something that need to be prioritized. Imagine that some bad guys or maybe adversarial that are leveraging issues or security issues on the software, and they abuse those software just to bypass parameters, even though how strong their security parameters there is. If their software is still vulnerable, it's still a big issue for them. So this is why we are still seeing all of these fail, even though software security has been improved. Like we see Microsoft started to killing bug classes and so on, right? And we know that all of this matter is not only from the major vendor like Microsoft, but those third-party software developers or third-party software vendors are required to follow all of this stuff in order to make these things a success, because the guidance is there. It's just that no one follow it because the reason may be performance issues, it's not applicable to their environment, and they don't have experts on doing so. They don't have much money to spend on security. So yeah, that's why we're still seeing this as a failure. So like I mentioned earlier about Microsoft has improved their security by killing and emulating bug classes. We can see a talk from Scape from Microsoft where they started to kill a lot of vulnerability classes, and these are being implemented in the operating system to avoid all of these. So we do see this chances from the vendors itself, major vendors itself, right? We just follow the guidelines to make it secure and so on. And yeah, exploit mitigations on different aspects, vulnerability become useless due to these mitigations. Most of the time, vulnerability nowadays become useless, where you just assuming that you fuzz something, and then you have a lot of findings. And then by looking into your results, you started to see like all of your findings are null pointer reference, something like that. When you're submitting or writing an exploit for that, it's almost impossible because you don't have anything to reference all your point or whatever data you are trying to exploiting. So nowadays, what we started to see also is finding vulnerability is hard. It's just that the better we rely on the maybe a third-party software like maybe antivirus. Like in the past, I did research on that. And also we started to see like a competitor between researchers, vendors, and boutique firms. So we can tell like FinSpy, a lot of bugs or vulnerabilities being used in there. It's just that the matter on the what we're seeing here basically is it from the researchers, from the vendors, or after 10 years being exploited, then that's what we started to like notice that something happening. It's just that we don't see it. So yeah, we started to see as well the exploit development costly. We know that exploit development is really require a lot of money, right? In order for large or for anyone to buy those things, and of course if you are providing those to a third-party vendor like ZDI or any other boutique firm, right? It depends on the criticality of the exploits and how far you can write an exploit to it, because nowadays writing an exploit is not an easy task, because you are required to chain to multiple bugs in order to successfully exploiting those. So hunting for vulnerability, right? In general, usually I started from lowest hanging fruit to the complex part. So in the previous work that I did, presented in Power of Community in South Korea on the hunting vulnerability in antivirus, covering various issues and methods as well in order to exploit it. There we started to look into like a DLL hijack that can escalate to privilege higher level, and to web API, web socket, and many other things, many aspects we are looking into. So those the lowest hanging fruit, just easy task to find one, but and of course a lot of reverse engineering required to in order to successfully find those. The methods are similar to like in the past where I did hunting bugs on AVs, because I did the fuzzings as well on the antivirus on the major antivirus vendors, and we do found a lot of antivirus engines vulnerability, like the parsers and the processing scanners and so on. So many other things that the methods are similar to like if you find on the different applications. It's just that depending on the target, like how you want to achieve those in order for you to exploit the things, or you want to find bugs. And of course, studying other researchers' write-ups and analyze from scratch to understand how it works is important. It helps to identify bugs and ideas on how to exploiting it. So this is the most important thing. Like, well, we don't know everything right in the world. Of course, like we need to know that someone has the new technique, or the easiest way to write exploits and so on, right? Or easiest way to find bugs. And yeah, we do have to like study on how do they discover it and how do they write it, and maybe from that idea that you have been reading, you get more idea like on how to enhance those in order for you to be more successful. So yeah, it's like a competition, but in different domains. So yeah, and of course, reverse engineering patches and updates is important as well to understand like you don't know this CVE is being assigned, right? And where is the bug lies on. So reverse engineering the patches and updates is important to understand like what has been fixed by the vendors and what or why these things are not exist on the new version or the new patch, and the old one it's still there. So from there you can tell that if you have a strong background in reverse engineering, you should be able to tell like on how to craft the exploits and or how to craft the proof of concept. That's the important thing. You understand the bug is there. It's just that on how you want to achieve to the target, or the one that you want to try to look into. So easiest way to hunt for vulnerability is the access to the source code. However, not all source code is available to public, right? Like the only thing that we are seeing is on the open source program. So I did open source fuzzing as well in the past, but for me it's pretty easy to do the fuzzing and so on, right? Or hunt for vulnerability. But yeah, something challenging like just a .exe file, right? And then you started from there, and you don't know where you want to end. And sometimes if you are like overwhelmed, or you might end up to a rabbit hole. So those are the important things. Yeah, a lot of reverse engineering process basically is involved here. It's just that we need to be smart on not to analyze everything, because by the time, for example, like IDA Pro load a program, and yeah, you can tell that where you want to start. It's not like the IDA load the executables, and you started from the one that you see on your screen, but in fact that you have to find where is the programs try to do processing or maybe parsing. So that's the place that you wanted to look into. And of course, yeah, reverse engineering is hard. It requires the patience and a lot of a patience, just a patience, right? Sometimes you might end up like want to had your bang your head to the wall, right? Because you don't know like how the things works. Because like if you are compiling a program, for example, it includes a structure, right? You don't see a structure in assembly, so you need to figure out like on how to make the structure, how you can find a similar structure, how you want to construct something similar. So yeah, one way to approach on hunting a vulnerability is to fuzz a program. Fuzzing basically fun, but it's hard to and may cause a disappointment. And it's similar to reverse engineering, because things like a fuzzing, if you don't know the starting point, or you don't know what is happening on the program itself, right? You never see what you want to target. You just blindly fuzzing it and you get the results. But in fact, you don't understand how the things work. There's a lot of publicly available fuzzer out there, from the dumb fuzzer to the smart code coverage fuzzer. So those are the important things to understand. Like you can start from the dumb fuzzer to the smart fuzzer, and you can find the difference there, and you know to hunt for the next variant or something like related. All right, so next one, fuzzing approach. My methodology are still relying on traditional methods such file format fuzzing. I like to do a mutational on byte and bit. I will call it for the win, because we never know that if the program has been patched, right? And then assuming that you perform a variant hunting, you should be able to catch more bugs. Actually, it's just that you need to know how to play on those bits or the bytes, whatever that you are targeting to. So traditional method is basically workable until today. It's just that it might be too slow, or it might be end up like you don't find anything. So you need to be smart on like how you want to make the things works properly. And yeah, so perform variant hunting APIs functions are important, because you need to understand like at this function or at this APIs, it tries to do something. If it is patched, you can see the previous unpatched version, and you can understand like what is being implemented, or there might be another attack surface that introduced there. It's just that we need to figure out like how to reach to that target or to that particular point that we want to fuzz. Dumb and smart fuzzers are most of the time you can find the custom one on GitHub and publicly available like a BFF, WNFL, and many other things. So we do see a lot of fuzzers being improved, like FL. There's a lot of versions from Windows to the Linux, Mac OS, and yeah, so many things that are being improved. It's just that the optimizations and code coverage guided. So the instrumentations are important as well to successfully fuzz or you have a fuzzing project. So the next one is during my fuzzing approach, I was assigned with numbers of the CVEs, including antivirus engines and a large complex application like a Microsoft Office. And yeah, so I did build a custom fuzzer, which is work on specific cases such file format and yeah, and of course, you know, a file format fuzzer is basically limited to the target itself, so it's pretty limited, and you don't have any other way to fuzz different kind of applications other than file format processing kind of program. So public fuzzer, I use that as well. I used to use CertBFF and WinFL. WinFL is supports the coverage guided, and you can just fuzz the specific APIs to see if triggers crashes and it introduces a vulnerability on that API. So, and yeah, and then the next one, CertBFF, the basic framework, fuzzing framework, is basically a file format. It's written purely in Python, and it supports a custom Python plugin. You can write your own mutational code and plug into the CertBFF, and the CertBFF just work as a framework. And yeah, basically whatever outputs being generated is responsible by the framework itself. So when I did the fuzzing, I noted down all the bugs that I found. So here's the fuzzing stats or results that I found. I focus on the Foxit reader, WPS Office, Microsoft Office, Windows GDI, Handcom Office, and the last one is a Nitro PDF. So that Nitro PDF is the one that interesting, where I did a fuzzing with the publicly available fuzzer called CertBFF, the Cert Basic Fuzzing Framework. It's kind of easy. You just need to find the on GitHub or PDF corpuses, and then just throw into the fuzzer. and you should be able to pick up a bug or vulnerability, even a real vulnerability. I do found numbers of vulnerabilities and reported to them and got rewarded with their bounty. I think they provide me an Amazon card. I used to buy a lot of things, a lot of stuff from the Amazon. Is from their gift. So yeah, it's kind of interesting to see like commercial applications of PDF reader. You can just easily fuzz using even if with someone that has zero or little knowledge of fuzzing, they can simply find one. But that's a cheat or shortcut way to do it, right? But and in fact, you have to understand the nature of the fuzzing itself, or like on building your own, and then try to find like a specific or make a difference on whatever available fuzzers out there. So yeah, talking about the public fuzzer just now, WinFL and Cert BFF are the main options on public available fuzzer. If you're fuzzing a program like a PDF or something that does a reading or does accepts an input, like maybe image magic, something like that, you can use like a Cert BFF. And you can write your own custom plugin in Python in order to. So the BFF itself, the Cert BFF itself, basically just a framework. It helps you generate and run and start new process attached to debugger and write output results and so on, right? And minimize corpus. But the main important thing you need to understand is like how you want to make your mutational code work there. So you can find a code from Stack Overflow or any other things, just implement yourself and try to learn like how you can utilize those fuzzing framework. So WinFL is a powerful and smart fuzzer. It's really fast. It depends on your harness as well, because the more you dig on the on your code, like for example, you parse more on the application itself, it could slow a bit the fuzzing performance. And the best thing about WinFL is supports instrumentation. So instrumentation is important because you want to see like where you have fuzz and what can you do for the next variant hunting. So this is where you want to use WinFL for this type of fuzzing activity. So next one is BFF. It's basically a traditional methods without coverage guided or instrumentation. It's just a blind fuzzer. It takes an input and then bit flip or byte flip all the whatever contents on the applications. So yeah, like I mentioned earlier, it supports Python plugin and of course you can write your own fuzzer. So the problem with BFF is the longer you run the framework, the slower it becomes. So when I fuzz Nitro PDF, it took around like 5 days to complete like 20,000 corpuses to fuzz. So yeah, in initial run, it took only like less than like maybe 12 hours. But yeah, because maybe the memory usage as well, because usually when I set a VM for the fuzzing is minimum is 8 gig, but yeah, still not enough. So I guess maybe 16 gig should be pretty enough to get it more faster compared to like whatever environment that I had set up. So yeah, public fuzzer, that when I did the fuzzing, I found numbers of vulnerability and was assigned with CVEs just for public record on vulnerability reported. And Nitro PDF and Nitro company has create some, I think, a page for the advisory and the accredited researchers. So the only problem when you work closely with them is they don't provide CVEs. You need to raise your own, and then they'll add all whatever info that you have requested to Mitre. So next page shows the numbers of issue found, and of course not only Nitro that I did the testing or fast testing, but there are many other software that I did the testing as well. I just don't include everything here. So yeah, This is the one that I did. So on the left side, MSRC case is where I reported to Microsoft, the MSRC team, and this was found in Windows GDI. There are more actually compared to what you're seeing here on the Windows GDI. It's just that we don't get luck when we reported because the attack vector is too low, and some of the issues considered as a moderate. If you see MSRC's severities level on reporting bug, if they rated it as a moderate, usually they don't fix it, and yeah, and it will get fixed only in the next maybe product cycles. So yeah, these Windows GDI bugs are basically found using a WinFL. We do have set up around 12 VMs on different harness and different APIs to target, and yeah, we do have a luck there. It's just that we don't get CVs or advisories being released on this. So on the right side, you see is the Nitro PDF software. There's a numbers of the CVEs, and this just the whatever that I able to provide here. So yeah, this was found with cert BFF, and it's quite pretty easy. Like I mentioned earlier, just throw the just find as much as you can the corpus, and then let the program do the job for you. So if you are smart enough, you can write your own plugin to get more bugs. There's a you can get the idea from the on the available code Python, and then maybe you can tweak a little on the code itself to get maybe a better performance or better reach to the target that you want to exploit or you want to fuzz. All right, so let's talk about custom fuzzer that I built. So file format fuzzing nowadays, I would say still effective, although a lot of people migrating to smart or coverage guided fuzzer. I know it's slow, and everyone know the file format fuzzer is slow, but and of course, when I built my own fuzzer, I do found numbers of vulnerabilities even in the complex application. So the main idea to find bug as much as it can, and this fuzzer only focus on the C, C++ types of application. It has a capability to fuzz a complex software because like a software that has accepts input, or you can set a parameter, right? As long as it supports parameter or inputs, it should be pretty easy to integrate with the fuzzer that I built. So it's able to catch bugs as well and minimize results. So it will write the outputs, and then it will create the whatever that trigger the crash and minimize the corpus to become the proof of concepts. And yeah, it's purely written in Python. So the idea of this is do a mutation on input file. You can see like an example file.exe, and then the input of your target. And then basically the fuzzer covers bit flip. I like to randomize range values like from 0 to FFFFF or 8 million, something like that. Or and of course I focus on bit flipping on the strings, and then special characters as well. So the custom fuzzer that I built are able to detect crashes via debugger. It's slow, but it works. There's I figured out that I could integrate the fuzzer that I built with something. There's a call bug ID from a guy from Netherlands. I think his name is Skyland on Twitter. So yeah, I used to integrate that once, but requires a lot of code writing. I'm a bit lazy to write the new the code, something like that. Right? It's just that it might take some time, but it should be workable. And yeah, I tested my fuzzer to integrate with to get the crashes detected via debugger, like using CDB by KD. and WinApp DBG. So yeah, and of course, the custom fuzzer that I built has a capability to turn off and turn on the page heap. All right, so next one, looking into these integers on my fuzzers that are implemented. So what I look into is signed and unsigned byte, signed and unsigned word, D word, and the keyword. So of course, I cover the negative numbers and the positive numbers. If you, like I mentioned earlier, the range of the values either from zero. So it depends on the whatever that I specify. So next one is strings and ASCII. So the strings and ASCII is important as well. You don't only focus 100% on the integers, but strings and ASCII could introduce a bug as well, right? Like we can take like an example of a format string or any other things, or it could trigger overflow on due to the large strings, empty strings, or and many other things that we can look into, like length tags modifications. We included null terminator after the program executing something, and the important one is append and prepend on tag string. So this is how the general idea on how the custom fuzzer works. So next one is demand problem when I build the custom fuzzers, right? It basically a trigger a false alarm, a lot of a false alarm, or we call it a false positive. You do excited when you fuzz applications and it detects crashes. However, when you look into the results, right, and you try to reproduce using the minimized POCs that generated by the fuzzers, and then you don't trigger anything, and sometimes it just trigger a null pointer. So yeah, those are our main challenge when you're building your own fuzzers, because you end up like you don't find anything, although it catch some exceptions, access violations or something like that. Yeah, so that's why what I did was splitting out the results by performing a better filtering. I did just check, for example, like the last exceptions, looking into the address, either null or has something on memory or the register. So these are the important things that I did. So in order for me to successfully eliminate, not to eliminate 100% on the false alarm, but it could reduce the numbers of false alarm. So the important info when catching crashes is looking into the results, or looking into the exceptions happen, like access violations. And then at the access violations, what is happening? We do see like a last crash disassembly code, and we can see like a register value, a stack trace. So these are the important things that we can implement as part of our fuzzer, because you want to see like which disassembly that causing this, because this crash, because from that crash, last point of the disassembly code shows the access violations happening. You can actually look into like the stack trace to maybe like understand like where is it actually triggering the crash before it reaches to the last this crash of the disassembly code. So yeah, those are the important things that, so yeah, sometimes the stack trace, when it gets generated, it doesn't give a consistent results. So it's inaccurate results. So you need to, of course, manually verify and debug the issue and of course replicate everything, like how you set in your environment of fuzzing, like had page heap enable and many other things that you have done on your fuzzing environment, so that you get a consistent results when you do a manual verifications. Because by the time you want to submit the bug, you need to have a solid and firm findings and write-ups before you submitting to the vendors. So how does the file format fuzzing that I built work? It's similar to like whatever that we have been seeing in the past. We have a file format, and then we have the input, and then and of course the only difference is just the custom data that I crafted, and then it supports bit flipping, and it does some random reference values, and then if there's a crashes happen, the fuzzers itself can detect and generate write and output, and minimize the corpus that trigger the exceptions. So maybe you are like wondering what's inside the custom fuzzer. So to be honest, no special code or techniques. Just a copycat code from the internet with major modifications. There's a lot of people write the code there outside there, and it's just that they don't do better, or they don't continue work on that project. Yeah, we never know that those type of code is basically important or basically useful in your test case. So yeah, like I said, no special code or techniques. And of course, it supports a bit flip. That's the important thing that I always keep in mind when I do this kind of fuzzing. No taint or guided features. It's basically fully file format fuzzer. Initial idea, I would like to build a framework, but it looks hard and used to it use a lot of your energies and times, right? So why bother on that, and just build a simple one that can satisfy yourself. So the custom fuzzer that I built basically caught a real vulnerability on complex software such as Microsoft Office. We can talk about it. I will talk about it later. It's slow, but I'm basically satisfied with its results. So there is no plan at the moment to release the custom fuzzer, because I still wanted to improve those that might missing, and something that I can improve for performance. All right, so this is how the actual works on the fuzzers. So we do have a input file, and then it will flip the input file, trigger crash, write output of last state of the fuzzer. So the last state of the fuzzer is where it detects or caught access violations, or any exceptions happen during this fuzzing state. So it will save whatever that file being mutated, the last that triggered the crash, write an output in text strings to tell that this assembly is causing this issue. So yeah, from there we can just open in, for example, like IDA Pro, and then look into the hex, and then find the bytes of the hex inside the IDA Pro, and we can tell that from there where we can look into and what caused the bug trigger there. So and of course it's a looping process. It will start a new process, and try to find the next file that it tries to process. So the main problem of the fuzzer that I built is it will sometimes it takes back the files or the corpuses that you have that it has processes, and it does not check on like if it is already used for fuzzing or not. So I could implement something that might check a hash of the file before maybe trigger before it starts the fuzzing, just to eliminate those repeatable, because in some cases I do see a lot of bugs being generated on the report or the output. However, the problem is you are seeing the same bugs actually being reported, so it's kind of a disappointment there is, but I figure that deleting files or maybe check the hash of the file is important after or before it starts the next fuzzing process. So let's take a look into a test case fuzzing example. So for this one, I targeting Handcom word processing applications. This vulnerability actually has been reported to KISA, Korean Internet Security Agency, I guess, if I recall. So the corpus size around 25 kilobyte. So what I did, focus on the bitflip mutation. The fuzzer supports. What I did is I changed the random range of values, which starts from 0x0 until 0x7 FFFF. So those are the range that basically being covered by the fuzzer and yeah. Bug was found after 4 hours running. There are basically 3 different vulnerability found. Basically, we can see the test case in the next page. So this is the actual bug. So this is what you are seeing here is I opened the file in the hexxd, and this is you can see on the left original file, and then on the right side is a mutated file. And then you can see the original file bytes on the 3B50 line, the one that gets highlighted 4C130F25, being mutated to 7FFFFF, but you see FE is behind there before it reached to the FF. And then, so by the time the word started to process and parse for the contents of the doc file, crashes is triggered due to malformed contents on the file formatting. So we can see it's pretty easy, right, to find one in a small. What we can demonstrate, what I demonstrate here is just a 25 kilobyte of file is basically small for a document, and in the mind, what I always keep is if it is a small size file, it doesn't introduce a lot of attack vector, because when it fuzz, it doesn't have so much place for it to do a bit flip. It's just waiting for luck for it to get crashed. But however, in this case, we know our target has a problem when processing a malformed contents on a small size of a Word file. So yeah. So what we see here, using a small size, we can demonstrate that these things are effective on the currently existing or the new patch kind of applications. So I think I was informed that this bug has been fixed. There's a numbers of issues. Basically, I have reported to them. It's just that waiting pending from them on the updates. So this is how the example minimize results. You can see it detects null there. If it is null pointer, it will say true. So meaning that the bug is useless. After that, it's just maybe you can trigger denial of service or any other things. But if the results shows null false, meaning that there's something happening on the memory or register that you can modify or you can override. As you can see, the registers EX and EBX with the results, with the register value bad BAD. And then the stack trace is where I was informing just now, where it could be inconsistent, so inaccurate. So you have to manually do debugging on it in order for you to get more understanding on this. So enough of the fuzzes that have been built and the success story of it and the failure of it. So we move on to the art and understanding the attack surface. So before that, right, before we started everything like a fuzzing, for example, basically we need to understand like how the mitigations takes place, and if we fuzz a program, right, does it trigger a crash on which place? Are we seeing the crash happening on the code, the actual code that we are targeting, or the crash happening on the maybe exceptions, just a normal exceptions triggered due to maybe stack exhaust, so something like that. So if, for example, if stack exhaustion, right, we know that there's already mitigations being take place. There is just that it keeps there's a recursion happening there, where maybe it keeps looping. It's just it's not a bug. It's just something that try to mitigate the memory override and so on, right? That what we have done using the fuzzer. So those are the important things, especially in the modern operating system nowadays when we do a fuzzing. So understand your target and the mitigations is important. So next one is you need to verify that the targets are really protected with current mitigation. Like I mentioned earlier, just now about the ASL are not implemented right in the modern operating system or era, right? Yeah, those are the things that we need to understand. So yeah, and of course, once we have everything right in hands, bugs, we don't call it a vulnerability yet, but just a bug. How far can we demonstrate the impact of the bug? Does it really exploitable, partially exploitable, or non-exploitable? So those are the important things that we need to take care of, because we don't want to end up like submitting bugs to the vendors, and then you end up like being rejected by them because you don't provide a firm or solid result to them. So yeah, and yeah, the last one is understanding your target is actually important. State the art. As you know, finding memory corruption used to be easy in the past and always have exploitable results. And we can see historically exploited for decades. And if you are working in antivirus companies, or if you are working in security companies, yeah, you can observe in the wild exploits, right? And yeah, because you are seeing like what's happening on your customers on sites, and yeah, you know that it has been exploited for many years in the wild. Even for example, like someone publicly write an exploit because and posted in on GitHub, and because a vendor that refused to fix that, and then within 3-4 days or within 24 hours, we security companies that does defense, right? And they started to see like exploits being exploited in the wild. So yeah, that's the I mean like the thing is happening. It's just that they have to wait for the time for researchers to publicly post or make them available on internet. So attack surface is always there. It's just the matter of understanding how it works. So this is the important part, and it's really hard to find actually a attack surface. Sometimes you see the attack surface there. It's just that you don't know how to trigger a bug there, or how to find bug at that particular point. But if you are looking carefully, you know that you can do something on that particular area. Yeah, so last one, I would like to state again that heavily involved reverse engineering processes is basically everywhere in terms of fuzzing, writing exploits, finding bugs, and so on. So RE is important, and you have to have a solid background in RE in order to be a successful bug hunter. So in the past, used to be that this easy, right? You see a stack with overflow. We know that what happened after the stack being overflow, we override the local buffer and other variables, and then we control the pointer and so on, right? And we have a user control data as well. That's where we maybe put our shellcode there. And so yeah, it used to be like it's this easy, and in the past when there is a CTF, there's always like this kind of a challenge, right? And it's pretty easy to pwn this type of binary. Same goes to the real world. In the past, it used to be easy. There's a lot of stack overflow, buffer overflow happening on the software, and of course there's many other things that are happening. Yeah, and then things become a little bit harder. I would say is a medium or intermediate level kind of exploitation, right? Where ROP is being introduced, and then there's a lot of work compared to the previous exploitation technique, where you need to find addresses to make it gadgets, and then to get a successful executions, something like that. So this is, I mean, like how the mitigations takes place to trying to like reduce attack surface on this type of issues. And then we started to see like control flow guard being implemented in most of the Microsoft binaries. And nowadays we do see a compiler, the Visual Studio. It has these CFGs options there you can enable in order to protect the binary. So yeah, this is another story of another level of exploitations. And yeah, if you are exploiting browsers uh, any other program or application that requires exploitation or bypassing CFGs, right? So a more headache for the researchers to write an exploit in order to successfully working on the exploits. So as you can see here, like the current version of Microsoft Access, as an example, it was implemented with a DEP enable, SLR enable. However, we see CFGs and stack protection is basically disabled, and we can see the DLLs are being shipped by the Microsoft Office, right? We don't see all of it being protected by CFG. So we know that the attack vector here is I would say not too easy, but if you know how to write an exploit and bypassing SLR or DP, it should be pretty easy to get a straightforward exploit. It's just that the operating system itself could maybe mitigate the exploit to work, but yeah, the surface is there. It's just that we need to find the bug there. So when I did a lot of reverse engineering on the applications, right, like word processing and so on, I encountered this disassembly snippet code where this code is basically allocating a memory. Basically, it triggers this after maybe if I recall, it's a buffer overflow or stack overflow. Any memory corruptions as well, it does detect, and once it detects, it will redirect to this. There's a pointer that basically assigned to this one, and it will. It helps the program to align your whatever that you are trying to do to its pointer that it's hard coded. I think it's hard coded if I recall. There's more code down there. It's just that it's just a simple code that I try to demonstrate. So yeah, some vendors are really good in protecting this, but however, if they don't implement include those mitigation that introduced by Microsoft, it's kind of useless to have this kind, because assuming that they hard-coded this pointer, right? You know that pointer you can abuse and use that as a code reuse maybe, or any other vectors in order to successfully exploit those things. So yeah, nowadays we started to see finding bugs is an easy task. Modern exploitation is very hard and expensive, and yeah, if you do found a vulnerability, right, you can actually write an exploit on that single bug to successfully achieve a powerful exploitation, but you have to chain to multiple bugs. We can see the trend in Pwn. It used to be like 1-2 bugs being chained. Nowadays, we do see like a couples of numbers of vulnerability being chained in order for them to achieve a powerful exploitation. And as you know, exploit development costs started to continue growing, because we started to see like maybe a government or nation state sponsor started to abuse exploit developments and yeah, and to pawn everyone in the world, right? So yeah, that's what makes the competitor between the researchers, boutique firm, and the vendors. So next one is the attack surface. So speaking about the attack surface, right, is basically the entry point on what you want to exploit. For example, like you found web APIs, and then how you want to exploit those. From where or what you start, and what is the entry point there you want to maybe find a bug there. So patches and fixes let us understand like what have been fixed previously, and it we never know it could introduce another bug, right? So we could consider that as an attack surface. So next one is variant hunting. Indeed, important as well, but it's super hard without a proper guided fuzzing. So like example, like my fuzzer, I don't see a variant hunting can be implemented because it's not a smart fuzzer, right? Or code coverage guided fuzzer. So you can see like a WinFL uh, is useful in this type of hunting because you can do a lot of because you need to code your own harness in order for you to successfully to find the attack surface there. Input processing and passing are the most common attack surface. If you are looking into those, these three are the main idea if you want to start to. So in my fuzzers, right, in the custom fuzzer that I built, it's basically found numbers of bugs on various software. So in this talk, I try to present a case study on Microsoft Access and Handcom word processor. So Microsoft did a great job on fixing, and they have informed me a future plan release as well to eliminate bugs that I have reported. So before I write this in my slide, right, I already asked a permission from them. Usually after they reply me the last email, like if the bug being fixed or not, I'll try to ask them like permissions to write write-ups on whatever findings that I found. So fun fact about Handcom, right? I reported the vulnerability to Kisa. However, no updates, no further updates from them on news on the reported bug. The last one they told me is there are like 3 or 4 bugs on the initial report that I provided to them. They told me like 1 or 2 bug has been fixed. So not until today I don't hear any news from them. So it's kind of sad because they are supposed to handle their things right. So let's take a look into a case study. This is the one that I reported to Microsoft in last year. It was assigned with CVE 2020-16-957. The bug itself is a Microsoft Access Connectivity Engine, RCE, Remote Code Execution Vulnerability. So the bug was found with my custom fuzzer, and Microsoft acknowledged me on their portal along with the CVEs that assigned to me. The idea fuzzing Microsoft Access is by feeding the fuzzer with the corpus like a extension MDB file, like more than 10 meg file. So like this bug that I found, it was found on the 31 MB file size, and I assume that there's a lot of bit flips happening inside there. That's why it could trigger the bug. So yeah. It's basically a heap corruptions vulnerability that was detected when handling specially crafted access database. And basically the bug is reproducible on Windows 10 x64 with the version 1909. So it's basically affected version was the MS Access 2016 with the version 16.0 13029. So how does the bug looks like, right? When the fuzzer caught the thing. So in this analysis, it's just a quick look into it. When the crash trigger, right? So this is the exceptions that basically generated, and when I manual verifying the bugs, I do find that it's similar to like what the fuzzer found. So you can see the bug here is basically an heap issue, right? You can tell that it could be exploitable as well. And by looking into the stack trace, we can see heap allocations happening there. And yeah, and it triggers until the whatever that triggers the crashes. So you can see that there's a align memories, RTL allocate heap, internal, and then debug allocate heap. That's where the heap actually triggers and that's so we know that the heap corruption is actually happening there. So next case study is MSRC case 60509. It's on the same application, MS Access 2016. It's a heap-based out of bounds with OOB read. So yeah, this was found with fuzzing as well, with the custom fuzzer that I built. When I reported to Microsoft, it took numbers of email threads to convince them to fix the bug. However, the final conclusion from them, they considered this as a vulnerability, but they rated it as a moderate because it's an info disclosure only. So meaning that that time there is no fix will be shipped for this vulnerability. However, they will include this fix as their non-major fix in the next product cycle. So yeah, looking into the analysis, right, we could see that mem copy trigger here. So in my so the custom fuzzer that I built basically triggers a lot of exceptions on the mem copy. So everyone know when it comes to mem copy, we know it's a serious issue. It's just that in this matter we see it's only like a 1 byte out of bounds with you can see the ESI being moved into the EX, right? So EX, if we take the lowest number is AL, right? It's only 1, so we know that here is 1 byte only triggers this kind of issue. But to write an exploit for it, it's super hard. I don't see an attack RCEs, attack vector like RCEs and so on. But I believe it could be useful for info disclosure, and it could be maybe how do we say this? Maybe we could chain with another vulnerability that can do some info leak, like maybe leak some image-based address and so on, right? So yeah, we never know. So yeah. So looking at the stack trace, we can see that after the functions MSAU of this get TCDIB, we know that the last one before trigger mem copy is basically a mem copy being implemented in the code of the MS Access. So the one that triggers the mem copy is basically on the VC runtime. So that's where the issue actually happening. So the case study number 3 is a OOB read bug as well. So when I reported this bug to Microsoft, they don't consider this as exploitable. However, they accept this as an OOB read issue. But the exploitability rating is actually how will say this it doesn't meet their servicing bar criteria. So they, unless they even ask me to like approve if I can do info disclosure or maybe some RCEs on the on this using this bug. But however, it's really hard to write one. So yeah, again, we see a mem copy here. There's a lot of mem copy, right? If you notice, we see here it triggers copying the ESI into the EDI, and we know that we could override there. It's just that the method that when I look further into this, is basically a 1 byte out of bounds read. And there is not much attack surface after the full analysis of the vulnerability. So if we look into the stack trace, we can see the ACE core DLL is the last one that being executed before it triggers the VC runtime mem copy. So we know that it does maybe you can see the last one, the access load string has HSCR embedded and create an expert serve opt, and it does parse something on there, and yeah, it triggers this OOB read. And then the case study number 4 is still on the same application, Microsoft Access heap corruption. So this there's a invalid pointer issue was detected on the Microsoft Access, and yeah, still the same found with the custom fuzzer that I wrote. So this is the one that pretty interesting bug that I found, and Microsoft refused to fix this, as they stated user are required to run VB script. So I'm not sure if they get what I've been writing to them, but what I'm seeing there is you don't have to run or enable, when you open a Microsoft Access or any other Microsoft Office program, right? When you open application with a VB script or any scripts being embedded, right? It will shows a bar there that saying that enable content. So in this case, right, I don't have to enable content, so I can trigger the bug right before the enable content was showing in the application. So basically the bug itself is when there's a specially crafted VB script that I did fuzz on the specific area on that VB script, and what I noticed that when the Microsoft Access open this fuzz file, right, it triggers the memory corruption right before the applications being open, or right before you click anything on the Microsoft Office Access. So as you can see, the analysis here, right, the access violations was triggered, and the symbols could not be found due to the VBE7. The DLL is actually not there on the exist. But when you see the last disassembly code VBE7 DLL and register server, you can see that basically there could be a potential heap invalid pointer issue or in the heap corruptions, right? On the VBA, on the VB script itself when it parse. So you know that this specially crafted file is basically can trigger a crash on these applications. So yeah, by looking into it, we know that it's only like I can't recall how many bytes that you can do override, but I don't do further analysis because they were not convinced to my suggestions on like how attacker could exploit this. So the scenario when I spoken to them is when I write an email to them is like assuming that attacker could exploit this vulnerability, and then they don't have to worry about the content filtering right on the Microsoft Office, and they just abuse this to bypass those in order to successfully execute the next phase of whatever that they're trying to exploit. So those are the main scenario that I feel like this is something that they should fix. So further analysis, right? So yeah, you can see here, right? There are like 2 bytes basically being override there. So you know that something can be achieved from here, right? So yeah, this is how I mean, like the proof of the exploitability. But I'm not sure. Maybe their engineers feel that it's really hard to construct the exploit, or I don't know. It's just that they told me not no fix for this one, because the measurement of the content security filtering, content filtering of the Microsoft Office is the one that they think it is a layer for the security, not to fix the bugs whatever exists on this one. So the last case study, Handcom words out of bounds with vulnerability. So basically, there's a heap OOB read vulnerability in the Handcom, and these the attacker could remotely exploit their victims and to convince the users to arbitrarily run the code in the context of the current users. So the target was on the product, and version affected was the Handcom Office 2020 with the version 11. So this vulnerability basically was found via fuzzing. So this is the quick analysis on the findings that I did. So you can see that we could control the pointer ex plus 0c, and then we could replace whatever in ECX, and assuming that the next instruction ECX being executed on the call or whatever that being called, right? We can actually run an arbitrary code there. So it's obvious bug there. You can see that the exploitability as well. So so this is the snippet of the stack trace. There are a lot of it. It's just that they are too long for me to pass here. So due to no symbols on this program, right? So we don't see so much anything. So there's a lot of reverse engineering that involved in this analysis. So looking into the heap is basically we can see the heap being corrupted, right? And looking into the address 34510 is basically that pointing to the corrupted heap. So okay, so vulnerability disclosure again and again, right? There's a lot of debates on this, and we are still seeing this until today. You name any vendors, or you name any boutique firm, you name any program that are still seeing these debates, right? And then of course we know that it's a painful processes, both parties, for researchers and vendors, and yeah, it's being a headache, painful, and that's why there's a what's so called no more free bug, something like that, right? Just not to provide anything to vendors. So yeah, those are the fun fact. Yeah, so we do see most vendors have vulnerability disclosure process. However, sometimes they just don't want to work closely with you. That's all. I've been dealing with numbers of vendors, large vendors as well in another country. It's a painful processes. They told me to report this, to report that, and by coming to this process, whatever that they guide me to do. But when it comes to the disclosing all the issues to them, right? They just silent, zip the mouth, and just let me leave me blank, something like that. So yeah, but and of course I don't always share findings on whatever that I've been found, even though the vendors don't fix, because we just what I did was trying to just minimize the attack surface, right? By not disclosing anything, even though they don't want to fix. So yeah, and yeah, disclosure. Some offer bounty and some don't. There's always a debates on this as well. We can see on Twitter there's a lot of people, researchers complaining that they submit multiple bugs, but they only paid with one single entry only, but they don't get paid for the rest of the bugs that they reported. So yeah, it's a pain. All right, so do's and don'ts when you do vulnerability disclosure, right? Just provide as much info to each the vendor's task. If you don't know, sometimes vendors can guide you on or show you like the way or how you resolve it. Like I used to work closely with Microsoft. They provide a lot of good knowledge to me that I don't aware. So that's why in the next reporting to them is easy for me to provide relevant info and easy for them to analyze, to verify everything. So if necessary, use all the mediums to inform vendors, Twitter, Facebook, any other things that you can use to contact them. Just contact them. I know it's pain, but you sometimes it might get attention to or media. You never know, or just contact someone on their security media, right, and tell them that you found something or something like that. It could be fun as well. Get some feedback from other researchers on disclosing vulnerability. So if you're not sure to report this bug, right, or how to disclose this to vendors, because you might end up like get sued and so on. Right? Just get some feedback because most of the researchers out there should have the experience on reporting bugs and so on. Just follow the standard vulnerability disclosure from Google Project Zero, which is 90 days perhaps, or depends on you. But yeah, if in your country, right, or in the company that you're targeting, in their country has a search, just get their search involved. When I work closely with Kisa, the search in Korea, South Korea. I just throw them all the relevant info that I want to report, and they are the one that are being the middleman to work on this. So just try to avoid public disclosure without notifying vendors, because you might end up like being sued or being I don't know, they call lawyers and so on, right, to get you trouble, right? So just try to avoid those and make sure to inform them if you want to make write-ups. So do not talk publicly on what you found, not until it gets fixed. So this is important things as well. So you need to look into this aspect. All right, so we come to the conclusion. Okay, all right. So what we can take here, right? So best defense is basically offense. So you need to attack in order to successfully defending. So it goes the same, like if you read the books like Art of War, the Sun Tzu, and if you play soccer or play any other things, games, right, and requires defense and offense, you know the strategy to get the better defense. You need to get a better offense. Finding bugs nowadays is super hard. It's like a needle in a haystack. You find one, it's a luck. And properly disclosing vulnerability to vendors, not until things get fixed. So make sure that they really just trust them with the fixes and so on, so that you're satisfied with your work and so on. So like me myself, I do it all of this in my free time. So I consider it as my part-time or in my free time, because I feel like it's a satisfaction for me to make them do work, something like that. So lastly, long life file format fuzzing. I know the modern era nowadays is different, right? Everything moves to smart guided code coverage and so on, but file format fuzzing is still indeed I would say it's relevant. It's just that you need to figure out like how you want to make the things work successfully. So yeah, all right, that's all about my talk today. I would like to say thanks again to ROOTCON organizer, and I feel like I want to visit Philippines after this. So yeah, and if you want to contact me, you can find me on Twitter. You just reverse my name, reverse string my name Nafiez to Zifan. You can follow me there, and you can follow my blog as well on the works that I have did in the past. So thank you again for listening, and have a great day. Hack the planet.